All right. Today, we are going to use those four relationships that we talked about yesterday to set up and solve equations. Okay, so the first four problems on here, okay, don't involve an actual equation. We're just trying to identify the measure of a certain angle. And these are the four different relationships that we talked about yesterday. Okay, so these first four are hopefully pretty straightforward, pretty simple. Okay, but it says find the measure. I also want to name the relationship that's happening here. Okay, so in the first one, what is the name of the relationship between these two angles? They're both right angles, yeah. But yeah, corresponding is what I was getting at. Right, so these are corresponding angles, and I know corresponding angles are always equal to each other. Right? So if this one's 90, this one's 90. How about in number 2? What's the name of the relationship between these two angles? Alternate interior. Right? Alternate because they're on opposite sides of the transversal, and interior because they're on the inside of the two parallel lines. So, what is the relationship between alternate interior angles? They're equal. So, if this one's 86, this one's 86. Plus, how about number 3? What's the name of that relationship?
Exterior.
Alternate exterior.
Is there any other kind of exterior?
We could have consecutive exterior, but we don't have. So that would be like on the same side of the transversal on the outside, but that we didn't really talk about that. That's not really. I don't know why that's not in the curriculum. We could say that those are supplementary angles, but it's not really part of the curriculum. I'm not sure why. All right. So, what is the relationship between alternate exterior? They are pretty far apart. They're drifting apart, I guess.
There's a friend I saw the other day.
I just call it.
Your parents are
Far away.
Yeah. So these two angles are equal to each other, right? And then the last relationship that we talked about, what would the name of this relationship be here?
Corresponding.
Corresponding. Consecutive interior.
Oh, that's what I mean. Yes, it is, because that's what we said over here.
Consecutive interior. Right? Consecutive means on the same side, interior on the inside. So we also call this same side interior. Right? But consecutive interior is probably more often what we'll see. So what's the relationship between these? They're both 96?
No.
They add to 180. They're supplementary.
I knew that.
So if this one's 96, this one would be 84. Okay, so corresponding alternate interior and alternate exterior are equal to each other. Consecutive interior, add to 180. Okay? Consecutive interior and consecutive exterior, yeah, would both add to 180.
Okay.
If we come across consecutive exterior. Alright, so let's take a look at setting up and solving some equations then. So, for number 5, how can I set up an equation to solve here? Okay? Equal to each other? Set them equal to each other. Right? I know that alternate exterior angles are equal to each other. So my equation here is going to be 9x minus 6 equals 8x plus 1. So go ahead and solve that real quick. Did we get 7? Is that my final answer? It says solve for x, right? So, yes, that is my final answer.
You put corresponding, not corresponding, no, alternate exterior.
The name of the relationship would be alternate exterior. Yeah, so we could, you don't have to, but I mean, it might be a good idea to jot that down. How about number 6? What's the relationship between these?
Vertical.
These are vertical. Okay? So our vertical angles equal to each other, add to 180, add to 90, equal to each other. Right? So my setup is going to be -5 plus 22x equals 105.
How did you do that stuff in your head?
I don't know. The division you mean? Or the...
Yeah. Like, one time
Well, I know 100 divided by 20 is 5. So that 10 divided by 5 is 2. Split things up like that, it's easy to do in your head.
the same, like, second point.
What do you oh, vertical. Alright, why don't you guys try 7 and 8 here?
I missed it.
Yeah.
What's the relationship between x?
Okay, you guys try 7 and 8.
What's the relationship between alternate exterior? What's the relationship? Equal to? Wait, is that alternate interior? Exterior. Oh.
I was really confused to really think here.
Or you can just kind of
I have no idea.
Couldn't say. Wait.
Yeah, not inside.
yeah.
And then these are the same.
Oh, can you get the next number for angle?
We can get a negative for x, but not for an actual angle measure.
I know angles can't be measured.
Right. Yeah. So as long as when I plug this value back in, I get positive numbers. Then we're good.
Yeah, if you still get 1.5. Yeah, you can get it. I know I heard negative.
I know.
No.
All right. Did we get 5 and negative 5? Okay, these were both alternate interior, right? So on both of them, we just set the expressions equal to each other. Any questions so far? All right, let's flip over to the back and take a look at a couple where we have to solve for both x and y. On number 9, I've got x's and y's. I've got 2 expressions that have an x in them, 1 expression that has a y. It's here.
I just know
So these 2 angles don't. We're talking about the ones that have x's, right? So they don't have a named relationship, right? This one's on the inside of the parallel lines. This one's on the outside. But what we can think about, right, is if this angle is 3x, well, this one would also be 3x, right? So those 2 angles would add 180, like Clayton said. So my first equation could be 3x plus 9x plus 12 equals 180. 12x plus 12. Subtract 12 over. And what is that, 14? Well, now, how would I solve for y?
X, 3x, 4, 42.
Right? So if I plug 14 in here, 3 times 14 would be 42. Right? So I can just say this angle is 42 degrees now. And now these 2 angles form a linear pair. So they would add to 180. So we can say 4y minus 10 plus 42 equals 180.
Could we plug the 14 into the 3x? Oh, the one that you wrote, and then them being corresponding exterior, so they're the same.
These would be consecutive exterior, so they would still add to 180 if they're both on the outside like that. But we could plug the x into this one and say these are alternate exteriors, so they're equal. We could do that. We plug it in here. But the 3x in this one would still add to 180. So combine like terms. Subtract the 32 over. Divide by 4, and what is that? 37. 100 divided by 4 is 25. 48 divided by 4 is 12. 25 plus 12 is 37. That's how I do things in my head. You split it up into easier problems that you know, that you can do quickly in your head.
I was always told to find the zero. I teach them 7, 17. But if you find 9 plus 8, add 9 plus 1, so that'd be 10. Still have 7 left over, so that's still 17.
All right, why don't you guys try 10?
What he does, he finds
So yeah, okay, so you extend so
Would that be
yeah, marks on there.
interior?
So
5Y
yeah,
and 3Y?
yeah, so yeah, this is this equation. Yeah, so
It's nothing to be okay with this. That's why you did it this way. 111, this equal 111, plus 2x, plus 13. These two together
that's I was 6.
I can't. I said 5Y minus 4. Yeah, no, look, I made it right there. Oh, I forgot the 0.
So I mean, like, it's kind of, you know, like trying to last people 1 year. What? Just add the sale. Like, it's a, No.
Does it make 23? 23? Okay.
Yeah, like the freezing time. Honestly, I feel like 100 ended.
All right, for number 10, I think we should get y equals 23 and x equals 28. To solve for y, okay, I can say that these two angles here would be supplementary. Okay, easiest way to think about it might be to say if this angle is 3y, this angle is 3y, so these two would add to 180. When we solve that, we get 23. Then I would take 23 and plug it back into either of these angles. Okay, but if I plug it into this one, okay, these two angles are corresponding, so they would be equal. So 3 times 23 is 69, so I would set 2x plus 13 equal to 69 and solve. I think we get 28. I'll show you here after we finish the last one. All right. So we've got one more to take a look at here.
Oh, for this one, do you have to find wire, or do you just find the angles? So
You want to find x and y. So if you know the angles, then these one find x and y, right?
why? What do you need?
On the last one here. On the last one here. We are told that these two lines are parallel. Okay? Remember, these arrows mean that these lines are parallel. It may be a good idea to kind of visualize extending these lines out, right? So then the figure will look more like what we've been dealing with. Okay, so if I have two parallel lines, well, I can cover up half of the diagram at a time, right? So it's probably going to be easier to deal with these ones down here first to solve for x. What would the relationship between these two be? Not corresponding. It's consecutive interior, right? They're on the same side of the transversal, both on the inside of the parallel line. So are they equal, or do they add 180? Add 180, right? So I mean, we don't even have to set up an equation, right? If this one's 120, what's this one? 60. So we found that x is equal to 60. So what can I do with that now? I can plug it into this one, right? So 3 times 60 is 180 minus 70 is 110. Okay, so if this angle is 110, now how can I use that to solve for what? Wait, say that again? I don't think these two angles would necessarily be equal to each other. What would the relationship between these two be? Yeah, they add to 180, right? Because they're a linear pair. Together they would make, so we 3y plus 40 plus 110 equals 180. Find my like terms over here. Subtract the 150 over. Divide by 3. We get y equals 10. We okay with those?